Hi guys, this is Vineet, and in today's video we will discuss about how you can specify computed columns in a table in SQL Server. Before I proceed ahead, I would request you all guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button, you will get a bell icon. Click on that bell icon and select all notifications to get notifications regarding all my future videos. Now let's discuss on some of the reasons why you should be subscribing to my channel. So let me select the highlighter and I will take you through these reasons one by one. So this is first reason. So if you have a dream, subscribe if you have a dream for a great career. If you have a dream for a high paying job, nice big house, nice car, good bank balance, and you have a dream of investments to make money for you. If you have such dreams and you know that you need a job with a high salary package to fulfill these dreams, then yeah, you should be subscribing to this channel, because in order to get a job with high salary package, you should be learning SQL skills. And in addition, you should be learning other skills as well. But yeah, SQL is the base. You should be learning SQL skills to get a job with high salary package, which will in turn give you all the other items like great career, high paying job, nice big house, etc. So if you have a dream for getting all these things by getting a job with high salary package, then you should be subscribing to this channel, because all these wishes can be fulfilled by getting a good job. Alright, now second reason could be if your salary is being completely consumed fully into paying the house EMIs, house rent, etc. You spend money on food, clothing, children, school fees, movies, travel, and at somewhere in the middle of the month you see that all of your salary has gone by fulfilling these obligations, and at that point you have determined that you need a job with high salary package. Then again, I would suggest you, if this is your situation, please go ahead and try learning SQL Server stuff. And for that you need to subscribe to my channel, because I provide quality stuff that can help you in fulfilling your wishes, which I think no other channel is providing uh, in that much detail. Alright, now third reason could be if you are doing a job for 9 hours and you're not getting time to read books to learn the quality SQL stuff. Because if you generally have a habit of reading SQL books, then yeah, I can agree on that books contains quality SQL Server stuff. But usually these days, after doing a job for 9 hours, we usually don't get time to go through books and perform all the practicals. We don't have that much time, right? And you, at that point, if you are looking for an alternative, so if you are looking for an alternative, instead of reading through the books, you just want to watch videos so that you can save on time to gain good quality education is in less amount of time, then yeah, you should be immediately subscribing to this channel. Now fourth reason could be if you are working with SQL Server in your job on a daily basis. So in this scenario, you have a job where you are working with SQL Server on a daily basis, and you feel that you do not have sufficient skills to perform your job role effectively or perform your work effectively. If this is the scenario with you, I would suggest you to immediately subscribe to this channel, because this channel will help you in learning good SQL Server skills, provided you need to spend time in watching videos, and you need to watch videos for a period of time spanning from 6 months to 1 year on a 1 year on a daily basis. If you watch videos on a daily basis, I can assure you that you will get SQL Server stuff in a year's time, and your skill will be very good after a year's span of time. And once you have a good skills in SQL Server, you will easily get a good job. Now I've also mentioned another reason, which is the fifth reason. If you are currently jobless, or if you are just a fresher, or if you are a fresher basically and you are looking for a job role in job roles like data analyst, data engineer, or any entry level roles where SQL Server is involved, and you want to get in a good job in a SQL Server domain. I've listed few domains like data analyst, data engineer, SQL production support, SQL developer. Then yeah, you should definitely be subscribing to this channel. So guys, I've listed few of the reasons. I've listed 5 reasons. So in case you have come across any other reasons while subscribing to this channel already, do post us those reasons why have you subscribed to this channel, so that I can get an idea on uh, what people think before subscribing to my channel. So I need to get an idea on that. So we need your help here. So do post us your comments, guys. Let's move ahead, and there are some points to remember while watching this video. So please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice. Perform any exercises in your lab and test environments only. Do not touch any production environments or production databases. We would like to know your thoughts regarding our videos. Please share your comments with us. Also, you can share your suggestions with us, any videos that you like us to make, any incidents with SQL Server, any benefits that you have reaped out of learning that you gained through my videos. Do share us your stories. We would love to read them, and we eagerly wait for your comments basically. So do post us your comments, guys. Now, in case you need the PDF copies of the notes that are discussed during the video, there are 2 methods. So the first method is the paid method, where you just need to specify the title by sending an email to me. Mention the title of the video and send the email to me at vermavane@gmail.com. So upon receiving your email, I will send you the payment link where you, upon making payment, you can download the PDF notes. Second method is the free method. So if you are already a subscriber to this channel, or if you are new to this channel, there's a subscribe button below this video. Click on that subscribe button. So once you click on that subscribe button, it will change to subscribe button. So take a screenshot of that area, including the subscribe button, my channel name, as well as the video title. So send that email to me on my email address vermavane@gmail.com. Upon receiving your email, I will check the subscription status and will send you the PDF notes directly over to the via the email to your email address. Now I have curated some playlists for you to watch, and the links for these playlists are available in the video description area. So I have majorly 6 playlists at present. So first one is the SQL Server Database Design playlist containing 57 videos at present. Next one is the SQL Server Tables playlist containing 14 videos. Business Continuity playlist containing around 50 videos. SQL Server Indexing containing around 10 videos. SQL Server Performance Tuning containing around 15 videos. SQL Server Integration Services, which is currently containing 11 videos. Videos in all these playlists are increasing day by day. Sorry, I was saying decreasing, but yeah, the videos in this playlist are increasing day by day. I keep on adding videos to all of these playlists under each area, and these playlists will eventually grow to containing more than 100 videos under each playlist category. Apart from this playlist, I have a channel page which is at youtube.com/@SQL by Vineet. So once you visit my channel page, you will see a subscribe button over there as well. You can subscribe from there as well. Apart from that, you will see a playlist specially curated for you as per your history preferences. And in addition, you will see trending videos playlist which you can watch. And in addition, you will also see all these 6 playlists mentioned over here. These playlists are also present on my channel page as well, so you can watch out these playlists from there as well. Apart from that, the links for these playlists are given in the video description area, so you can check the video description area of this video. Now let's come back to today's topic, which is how to specify computed columns in a table in SQL Server. So let's quickly go to notes here. Alright, let me go through this theory, and there will be demos. There will be like 4 demos which we will be covering, so stay in tune. Theory part is quite short, so let's quickly go through it. So today's topic is how to specify the computed columns in a table in SQL Server. Now what is a computed column? So computed column is something where some computation is done. So let's go through the section paragraph now. A computed column is basically a virtual column. It is not an actual column in a table that isn't physically stored in the table. So computed column is not stored in the table unless it is marked as persisted. So if a computed column is marked as persisted, the data for that computed column will be stored in the table, otherwise not. So unless we mark that column as persisted, the computed column, it will not be stored in a table. Now, a computed column expression can use data from other columns in a table to calculate the value for the column to which it belongs. You can specify an expression for a computed column in SQL Server by using the SQL Server Management Studio, which is SSMS. We can specify the definition of a computed column or specify the expression for computed column by using the Transact-SQL statements as well. Now let's discuss about some of the restrictions on the computed column. So first restriction is a computed column cannot be used as a default or foreign key constraint definition. So computed columns cannot take part in becoming primary key, or we cannot define default constraint on a computed column or a foreign key constraint on a computed column. Or with the not null constraint, we cannot specify the not null constraint on a computed column. However, if the computed column value is defined by a deterministic expression, so this is true for the situation where the expression is not deterministic. So if we have a deterministic expression where every time the result will be same, those expressions are called deterministic expression. So if the computed column will give us a deterministic expression every time, or if it uses the deterministic expression to give the same results every time, then yeah, that column can be used for defining the default constraint, or we can imply foreign key constraint on that column, and we can also define null constraint on that column as well. So if a computed column value is defined by a deterministic expression and the data type of the result is allowed in the index column, so the data type of that computed column should be such that that particular data type is allowed for index column, then yeah, these constraints can be defined on that particular computed column. So these two conditions, if the result of a computed column value is defined by a deterministic expression, which is condition number 1, and second condition is that data type of the result is allowed in the index column, which is condition number 2. Now if these two conditions are true, a computed column can be used as a key column in an index or as a part of the primary key or unique constraint as well, in addition to these constraints. Now let me explain it again. There is a slight difference. So this is true that the computed column cannot be we cannot define a default constraint, foreign key constraint, and not null constraint on a computed column. Sorry. So we cannot define these three constraints, that's for sure, on a computed column. However, now this is a separate area. So this is absolute true that under any circumstances, under any condition, we cannot use the computed column in defining a default constraint, foreign key constraint, or a not null constraint. We cannot define these constraints on such a column which is using a computed expression. Now another section starts now, which is talking about if your computed column is deterministic, using a deterministic expression, and the data type of that particular column can be used for the data type allowed for index columns. This is separate scenario, guys. Can be another paragraph, but this is not related to this paragraph. So this section is absolutely not allowed. These constraints are absolutely not allowed on the computed column. Now this section is separate. It is talking about if your computed column is using a deterministic expression and the data type of a result is allowed in the index columns, then that particular computed column can be used as a key column in an index. So we can create index on such columns or such computed columns where it is using deterministic expression and data type is allowed for the index columns. and its data type is a load for index columns. So we can use those computed columns as key columns in an index, or used as part of any of the primary keys or unique constants. Those columns can be used for defining the primary key or unique constant as well, where the expression for the computed column is deterministic and data type is allowed for index columns. So this is done. Now for example, let's take an example. If a table has integer columns A and B, so there is a table where we have integer columns A and B, and we are creating a computed column by using the expression A plus B. Now if we take a look at this expression A plus B, this is a deterministic expression. So these type of computed columns using these expressions, these can be indexed because int is allowed for integer data type is allowed for primary key columns or defining any indexes, and here the expression is also deterministic. A plus B will always give same results for same set of values. But if the expression is different, or if a computed column is defined as A plus and we are using some date part function which is currently using get date, and it changes, this get date changes on every invocation of that computed column calculation of value for the computed column. So get date gives you the current date time. So this expression, total expression, is non-deterministic because it does not give you the same result every time. So these type of computed columns cannot be indexed because the value might change in subsequent invocations. So I hope you got this point. So these constants are not allowed at all, the default foreign key and not null constants, whereas primary key constants and unique constants can be defined on the computed column provided two of the conditions are true. First condition is the expression of that computed column should be deterministic and the data type of the result is allowed for index columns. These two criteria must be true if you want to define primary key constant or unique constant on a particular column. Now second restriction is a computed column can't be a target of a insert or update statement. So we cannot insert any values or update any values in the computed column because the values in the computed columns are computed automatically. We don't insert or update the computed columns. Now if we need to turn on the set quoted identifier, this must be on when you are creating or changing indexes on computed columns or index views. So if we are creating a index on a computed column, this quoted identifier option should be turned to on. Or if we are even creating an index view where we are using computed columns, then yeah, this option should be turned on if we are creating an index on a computed column. Now let me take you through some of the demos. The first demo is, let me see, the first demo is on how you can use the SQL Server Management Studio to add a new computed column. So let me take you through this demo. Give me a few minutes, guys. So alright, I'm taking you through this two demos. So first is using SSMS to add a new computed column, and the second demo is using SSMS to add computed column definition to an existing column where the column is defined already exist, and if you want to add the computed column in the existing definition. Alright, so let me show you the scenario where you can start from scratch, and also discuss the second scenario where table is already defined. So let's go inside SQL Server. Let's use the database sample DB in this case. Let's see what tables are in there. So what I will do, let me drop this products table. So let me drop it first. So I can use the command drop table products. I will create it from scratch. So let's drop this table. So we executed the statement. Now this table is dropped. Let's close this query and refresh the table section. We won't see this table. So product is not present over here anymore. So how you can create a product table using SQL Server Management Studio? In the Object Explorer, you need to expand the table to which you want to add the computed column. So here we are not using an existing table, we are creating a table from scratch. So let's first create a table, then we will add a computed column into that. So right now we are not adding any computed column. So let me do that. Let's create a table first of all. So you need to go into, you need to right click on the table and you need to do new table. It will open up a SQL Server Table Designer. Now let's define some of the columns for this table. So you may add product ID of integer type, and let's does not allow alright, let's configure some additional properties for this column. So it does not allow nulls, and let's see if we have identity property over here. So we have identity specification section. If you can expand, I want to set it to yes. So under is identity, you need to set it's an identity column, and we taking seed and increment values as well. So the values will start though this column will auto populate with the identity values. So starting value would be 1, and there will be an increment of 1 for every subsequent rows. So next value would be 2, 3, 4, etc. So I've set it. Give me a minute, guys. So guys, we have defined this product ID column as an identity column with a seed value of 1 and increment value of 1, and it is an integer type column, not allowing null values. Let's take another column which could be quantity available. So quantity available for product, I'm taking this as a small int, and this column will allow null. And let's take a unit price of this product, and I'm taking it as money, and it also allows null. So this is my table definition. Let me go ahead and save that. So if you close this, it will ask you to save. Just save it, and you need to provide name. So name of our table will be products here. So let me save this table. Now if you refresh the table section, you will see this particular table name. Alright, so products table is now here. Now let me show you how you can use the SQL Server Management Studio. Now we need to add a computed column in this particular table. So this is an already existing table. So if you want to add a computed column, you need to select the column section and right click on it, and you need to select new column over here. It will again open up the table designer. So in the end, you need to enter the column name. So let me see what column name needs to be added. So let's see what column we can take. So let's take a column, maybe inventory value, which can be if I take this section inventory value, I'm defining an inventory column value, and we are taking it as, by default it gives nchar 10, and you need to change it to, so you take it as default value, default value or default data type. You do not specify the data type for this particular column, which is a computed column. In our case, inventory value will be a computed column, which will be a multiplication of unit price into quantity available. This is the multiplication of these two, second and third column. So I'm leaving this nchar 10 as default over here. So we need to accept a default data type nchar 10. And the database engine basically determines the data type of computed column by applying the rules of data type precedence to the expression specified in the formula. So formula here will be quantity available into unit price. So SQL Server automatically determines small int into money and will associate a data type accordingly to inventory value computed column. So let's go ahead and see where you can specify that expression for that computed column. Now we were talking about that the data type is for the computed column will be determined automatically by default at text and cat 10 if we do not specify any expression. And let's take an example. If the formula references a column of type money, all right, and a column of type int, you can take small int as int. So if there are these two type of columns, the computed column will be of type money. In this case, if we multiply quantity available with unit price, the resulted column would be money data type. Alright, so if we take computed column as a product of quantity available and unit price, the data type of inventory value will be money data type, because the money data type has the higher precedence. Now in the column properties tab, we need to expand the column specification property. So these are the column specifications over here. So this is the computed column. These are the specifications for the computed column. So there is a formula section over here. Let's try to locate that. Let's see if we see any computation which can be allowed on this column. So we are on the column properties tab. We need to expand the computed column specification. So these are the categories. Let's see if the computed column specification are coming under the general data type. They are not. Now let's expand the table designer and see. So we have a section under table designer where a computed column specification can be defined, how the computed column can be calculated. So we need to expand this section. So under that section we will see a formula how the result of this particular inventory column will be calculated. And in the formula child property, basically we need to enter the expression for this column in the grid cell to the right. For example, for this column inventory value, we can specify it as a multiplication of maybe quantity available column multiplied by inventory value. No, not inventory value, but the unit price, sorry. So it's a result of second and third column multiplied, we get the inventory value. So I'm specifying the formula over here, which will basically multiply the quantity available with unit price and assign those values to the inventory value column. Alright, so formula is defined now, and it is saying error validating the formula for column inventory value. You want to cancel your changes? I am saying no. So formula should be defined by, I think, equal to need to be specified. So it is giving me error. Don't know why. So spellings are incorrect over here. If we see, we need to specify the correct spelling. So under the formula we should specify the correct spelling of the column. So quantity available is one column and unit price. Now the spellings are correct, it should allow us. So it has taken the column specifications now, which is the result of quantity available into unit price. Now let me discuss one of the important points. When a formula combines two expression of different data types, in our case we are combining different data types, small, int and money. The rules of the data type precedence specify that the data type with the lower precedence is converted. So here the data type with the lower precedence is small int. It will be converted into money automatically, into a data type of higher precedence. Money has a higher precedence data type, and there will be implicit conversion from small int to money value for quantity available data. If the conversion is not supported, implicit conversion, the error may occur. If the conversion is not possible, or implicit conversion is not possible for changing the data type, if we are mixing two data types, then we get the error validating the formula for column that we were just getting few minutes back. But we were getting that error because the computed value column specification, we were not using the appropriate we were not using the correct name for the column. That's why we were getting the error. But in case you will also get the same error if the data types if we are mixing data type that do not allow the implicit conversion. So in those cases as well, we get error validating the formula for column name is returned. And basically we need to do some explicit conversion in this formula bar using the cast or convert function to resolve the data type conflict. But in our case, there was smooth implicit conversion, so we are not doing any explicit conversion over here. Now let me give you an example where the implicit conversion will not happen. So in our case, implicit conversion has happened, but let me give an example where implicit conversion will not happen. So if one of the column there's a one of column which is using the n varchar data type, and this column is combined with a column of type int. So we are combining n varchar with the column type int. The integer type must be converted into n varchar. Alright. So n varchar has the highest precedence than the integer type, and integer type has to be converted into n varchar. And this will not be an implicit conversion, and we need to explicitly convert that integer value over here in the formula bar to n varchar type. But in our case, these are totally numerical types. Small int is also numerical type, and money is also numerical type. So there will be implicit conversion, and it's not giving us any errors. So I think guys you got the idea. If the data types, we are mixing data types that are where the implicit conversion is not possible, then you need to do explicit conversion in the formula bar. And we can also say if the data is persisted. By data persistence we mean whether the data for the computer column is stored in the table itself. So if you want to store the data in the table for the computer column, then we can mark it as persisted. So let's take it as persisted maybe. Otherwise we can keep it as no, because the expression is a deterministic expression over here. It will not change. So it will give us result on every select statement. So right now we don't have even any data on this table. So we are just defining how you can create a computed column. So we have created it here. Let's now save the table name and see what. So here data type is not defined for this column. Let me close the table definition and try to let me refresh the column section. So it has a inventory value column, which is a computed column mentioned by here in the within the brackets. It's a computed column, and the data type is automatically calculated as money because it's a product of small int and money. Now the data type assigned to this column is money. Alright, so guys, we are done with demo 1, where I've shown you how to use SSMS to add a new computed column to an existing table. Now let me show you how to use SSMS to add a computed column definition to an existing column. Let me see. I think both of these practicals are same because we have used an existing table, so I think we have covered both of them. But let's see what next we can see. Okay, so this demo is on how you can add a computed column definition to an existing column. But yeah, I've created a new column. I'm not adding a definition to an existing column, but otherwise what you can do, you can modify the table here by going into design view. And if there is an existing column which is not a computed column, maybe if inventory value was already there and it's not a computed column and you want to make it computed column, you can modify the table structure definition from here. You can put the computed column statements. You can define the formula to make an existing column a computed column. So I think that is not much useful, but yeah, you can do that. So if you have an existing column and want to make it a computed column, you can do that so by modifying the table structure and modifying the column definition over here and specify a formula for that particular column. Now let me close that. I don't want to make any changes. I think we are done with the table designer part. We have shown you how you can add a computed column. So these two demos are done. Let me show you how you can use the same thing using the Transact-SQL. Alright, So let me show you how you can add a computed column when creating a table. So let's cover the third demo. Now let me drop this table. You see we have created a computed column over here using the SQL Server Management Studio, and I hope you got the idea how you can create it graphically. Now let me delete this table quickly. I'm dropping this table. So this is done. So products table is not present anymore. Let me create the same table via the Transact-SQL statement. So I'm creating a table using the create table statement, and I'm marking the table name as db.products. Alright guys, so let's continue writing code. So you need to create a table, create table db.products, the same table. Let's specify the table definition within the bracket. So first column will be the product ID column. It's of integer type, and it will be an identity column. The column which are marked as identity, the values in that column are automatically populated. So we are taking seed value as 1 and increment value as 1. So it will start at 1 and increment values by 1 for each row, and we are taking it as not null. Let's specify this next column, which will be quantity available. Let's make sure spelling name are correct. I'm taking it as small int, and it will allow null. By default, a column allows the nulls within them. Next column is the unit price, which will be of money data type. It will accept nulls. And now I'm defining a computed column, which will be inventory value. Alright, and for defining computed column, you use the as statement here, as keyword. So we are defining inventory value column as the product of these two columns, which is quantity available multiplied by unit price. So please see the syntax here, specifically this line. How do you define a computed column? So inventory value will be a product of these two columns, quantity available and unit price. So we have defined a table. Let's execute and create this table. Now the table is created. We can refresh the table section to see products table should be there within the sample DB. So product table is there. Now let's insert some values into the table. So let me insert values into the table. This is a comment. Let's start the statement. So in order to insert values, you use the insert into statement, and you need to specify the table name dbo.products in our case, and we specify the columns where we are inserting the values. So we cannot insert any values in the product ID column. That is an automated the values will get automatically filled inside the product ID column. So we need to specify the value for two columns, quantity available and unit price only. So let me take those values here, quantity available, and second column will be unit price, where we are putting in the values. Now let me put values. We are putting two rows. So first row will have a value 25 for quantity available, and for unit price we are taking 2.00. And let's take a second set where the quantity available is 10 and the unit price is 1.5. Now this is done. Let's end it with semicolon. Let me execute this statement, and two rows will get inserted into table. Now we can select let's display the data. So display the rows in the table. How to display? We have inserted two rows. Now let me fetch those rows out. So let's select all the columns. Let's select the product ID, and let's select quantity available. Make sure the column names are defined correctly, and unit price will be the third column of the table, and inventory value will be the fourth column. And inventory value is a computed column, to remember that. So we are selecting these four columns from the table dbo.products. So in our case, this is an automated column where the column values are filling in automatically as per the identity specified here, starting with 1, increasing by 1 eventually. Quantity available, we have filled the values 25 and 10. for that column. For unit price, we have filled in 2 and 1.5, and inventory value is automatically computed, which will be the product of quantity available and unit price. So let's get the data out and let's try to execute the statement. We got the two rows, product ID 1, quantity available is 25, unit price is 2, and 25 into 2 is 50. We got the inventory value. Similarly, in the second column, product ID is 2, quantity available is 10, unit price is 1.5, and the inventory value is 10 into 1.50, which is 15. So this is in this case the inventory column is the computed column. Alright, and values are being computed automatically. Now let's try to do some updates on this table. Let's update some values in the table. You can write this code along with me and check your results at the same time. So let me do an update on db.products table. Please see the syntax. We are setting the value of unit price equals 2.5, and for which particular product, where product ID is 1, I am changing the unit price from 2 to 2.5. So once it is changed from 2 to 2.5, the value of the inventory value column will change automatically from 50 to I think 75 it will change. So let's see. So where I can specify the condition where to make these updates. So where the product ID is 1, we can change the unit price to 2.5. So let's execute this statement. Alright, so now if we will see all the columns in the table after we have made this change to unit price, we will see the inventory value of that particular first row will be 75, not 75. So it's 25 times 2.50, which comes down to 62.50. Alright, and this is how it is calculated. So this value depends upon the input parameter, which are these two columns. It's a product of these two columns, so we get values accordingly. If we make updates to any of these values, the resultant inventory value, which is a computed column value, will change automatically. So guys, we are done with 3 demo. We have 3 demos. In the third demo, I have shown you how you can use the Transact-SQL statement to create a table. In that table, how you can define the computed column. In our case, it's an inventory value column. We need to use the as keyword, and we can take the formula after that to be defined for this computed column. And we have shown you how you can insert the values in that table. And the computed we have shown you how the computed volume the values are automatically computed for the computed column in the particular table. Alright, let's go through fourth demo. Now let me show you how you can use Transact-SQL to add a new computed column to an existing table. So our table contains one computed column at present, which is the inventory value column. Now let me add another column to the this particular table. So in order to add a new computed column to this same table, we need to alter the table. So in our case, the table name is dbo.products. Alright, and after altering this table, what we want to add? We want to add a new column. So we need to specify the column name. So you can specify add column specifically, but yeah, if we just give column name, it automatically determines that it's a column which we are trying to add. So we are adding this column as, we need to take as because we are specifying the formula. So retail value will be a computed column which will be a product of quantity available. Let's take the formula as quantity available. Spelling, make sure spelling should be correct. So quantity available into unit price we are taking, and we are further taking we are further multiplying it by 1.5 to get the retail value, I mean the selling value. We are taking it as, we are taking a margin of 1.5, and we are multiplying the total inventory multiplying quantity available with unit price, and we are multiplying that product with 1.5 to determine the retail value. So we are adding this value column as well. This is a computed column in addition to inventory value, which is also a computed column. So let's add that. Now this column is added, and we can check it by specifying it here. We can specify it as a retail value maybe. Alright, and let's select retail value as well. So retail value is also calculated, and it's a product of 25 into 2.50 into 1.5. And similarly for second row, the retail value is product of 10 into 1.50 into 1.5, so which comes down to 22.5. So guys, I've shown you. Now this table has two computed columns. The first one is inventory value, the second one is retail value. So I've shown you guys how you can add an computed column to an existing table. Now let me show you how you can okay, let's add another column, and let's take that column as a persisted column. Let me try to make that column as persisted column. So let me take another column which is the sale value maybe. So we are altering the table db.products, and we are adding column sell value, and we are taking as we are specifying the formula here. So we are taking it as a product of quantity available into unit price into 2. And if we want to store the data of this column in the table, then we need to mark this column as persisted. For that you need to use the persisted keyword over here. Otherwise the values for the computed column do not get stored in the table itself within the disk if the column is not marked as persisted. So for example, the values for inventory column, inventory value table, and the retail value table will not be there in the products table. It is not stored on the disk. It's calculated at the runtime only. So if the columns are marked as persisted, the values get stored in the table itself as well. So let me modify this table. Adding a column. So a new column is added, which is sell value as well. So we can get the data from that column as well. You can specify it here, sell value. Let's execute it. So we get the value for the sell value column, which is a product of quantity available into unit price into 2. We got these values here, and this column is a persisted column, whereas the other two columns are not persisted column. The data for the persisted columns get saved in the table, whereas the data for columns that are not marked as persisted are not stored within the table. That's the only difference, guys. Now let me go ahead and remove these columns, some of the columns. So let me drop the retail value and the sell value column maybe. So let me show you how you can drop certain values. So let me drop the retail value column, how you can drop it. So I'm altering the table and dbo.products, and what I'm doing is here is, if you want to drop any computed columns, you can simply use the drop column statement, and you need to specify the name of the column. So here we are removing the retail value column, and basically we are doing this to change the formula. So we cannot change the formula directly over here. So first we need to drop the column, and then you need to specify the same column with the new formula. So retail value formula was let me show you. Retail value formula was this. Okay, this was the formula for retail value, quantity available into unit price into 1.5. This was the original formula. So if you want to change the formula, you can drop the column, add the column again with the new formula. So the drop column syntax is this. So let me remove that. So retail value column is now dropped. If we try to run this statement, it will give us an error because the retail value column is not available anymore. It is saying that invalid column name retail value. So let me remove that and try to run this SQL. Now sell value column is there. Now if you again want to add the retail value with the new column, simply you can use the same statement, alter table db.products, and you can specify add column statement, but column you don't need to specify. But yeah, you can specify it like this: add retail value, and you can specify the as clause, and you can take it as the new formula, maybe quantity available into unit price. Maybe this time, instead of taking into 1.5, let's take it as plus 1.5 maybe. Alright, let's alter the formula and add the column like this and execute the statement. It will add the retail value column with the new formula. Now it is added. Now let me add this column name to the select statement here. Retail value, I'm adding it here. So now the retail value column has a new formula, which the formula is this now: quantity available into unit price plus 1.5 is the retail value. Alright, so guys, we have just shown you how you can remove certain columns. So guys, we have shown you how to remove certain columns that are computed columns, and the syntax is basically the same for other columns as well, but in our case we are removing the computed column. So we have removed the retail value computed column and added the same column with a different formula. So I hope you got the syntax, and we are done with this demo 4 as well. So guys, I hope you like this video. In this video we have talked about how you can specify the computed columns, how you can add a computed column in a particular table using the SQL Server Management Studio and Transact-SQL. We have covered 4 demos over here. So I hope you like this video. In case you really like this video, please click on the like button below this video. And also please, if you are new to this channel, please go ahead and immediately subscribe to this channel. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. Also guys, please post in your comments regarding any suggestions you want to make, or if you have a request for certain videos to be created, please do let us know. In case you have any stories to be shared related to SQL Server, you can share those with us. And also, if you have got any benefit out of the videos in your day-to-day life by watching my videos, then do let us know via your comments. We would love to hear your stories, and we eagerly wait for your comments as well. And also guys, we need help from your end. If you have a good network of friends, then and they are dealing in the same domain, which is SQL Server, or they are from the IT background, please share my videos with them in case you feel my videos are useful for them as well. And please ask all your friends which are working in SQL domain to subscribe to my channel, as I am creating videos which will be very useful for them, and I would like to benefit the larger part of the society by creating exciting videos that can enhance the knowledge in SQL Server domain. So we need your help here guys in spreading my videos all over your friends network. So help us here. Thank you so much for your time on this video today guys, and you have a wonderful day ahead.